For our next problem here, I'll give you a chance to take a look of all this. So I'm going to go ahead and read through all this for you and kind of describe. There's a picture that's being provided for you here. Of course, you can always stop the video at any time if you need to have some time to take all this down. So an open box of maximum volume is made from a square piece of material 24 inches on a side, and we're cutting out squares from the corners. So here's the picture. You have a square piece of material that's there, and it's 24 by 24, and what we're doing is we're cutting out these little corners, and what will happen is we're folding along these dotted lines, so it's going to fold out towards you, so kind of out of the board, if you can picture that, and it's going to end up looking like this. So we're calling X the dimensions of the sides of the square that we're cutting out to fold it up into this one. So what will happen is if you have the whole side is 24 and you have an X here and an X there, if you remove those X's, that means you're left with a 24 minus 2X. So this side's 24 minus 2X, and this between here, this dotted line right there, that'll be 24 minus 2X as well. That's why you get both of them down there when you turn it into a box and it has a height of X. So that's kind of what's happening with the first sentence. So all that describes that, and the figure again was provided on this one. Okay, so then it says write an equation for the volume V of the box as a function of X. So we have to do that first, and then afterwards it says find the maximum volume, and that's where we're going to use calculus. So the very first thing we have to do is get the equation that we have to use in order to set up the equation to use for the derivative. So first, our volume for a box, it's equal to length times width times height. So even though it's an open box like that, it's okay. There's no top on it, but that's not going to matter. We're going to assume that's covered, and we're going to do the volume of the inside. So length, width, height. So what we have here is I have 24 minus 2x, that's the length. And then the width, actually they're both the same, so it doesn't really matter which one's length and which one's width. They're both the same here. And then times the height. So length, width, height. Now, what I wrote here, this V, this is a very common mistake that students make. Technically it's not V. You want to make it V of X. Now the reason why is because it says find the volume of the box as a function of X. That means you have to write that in function notation. So it's got to be written that way, V of X. Now of course we can simplify this. V of X is X times 24 minus 2X squared, because there's two of them. This right here answers the first question. So the volume of the box is a function of X. That's this right here. It means that X is the only variable in that particular equation, and we have the correct function notation. Now, the next thing it says find the maximum volume of the box. The first thing we have to do is take the derivative, set it equal to 0. We're going to solve for X, and then we'll put the X back into here. That's going to give us our volume. So we need to do derivative. Now when I do derivative here, we're going to have to use a product rule on this, and we're also going to have to do a combined chain rule. So I'm going to erase this to give us some more space. Now that we have the equation, we know what it looks like, let's jump down to this. So we're going to do the derivative is equal to, okay, so product rule, we got the first thing. When we do the derivative the second, that requires chain rule. Okay, so the 2 is going to come down. I have 24 minus 2x. Subtract 1 from the exponent, you'll get a 1 there. Don't forget to multiply by the derivative of the inside, which is going to be negative 2. Then, plus the second thing, 24 minus 2x squared, times the derivative of the first. The first term is x, which is going to be a 1. Now because you're going to have to set things equal to 0, it's better to have this in a factor form. Now you could expand all this out, but that's a lot more work than you have to do. It's going to be better to do factoring on this. So what I'm going to do is I need to set it equal to 0, but I'm going to do a factoring step first. I see that there's a repeated 24 minus 2x term that's there. So I'm going to factor out 24 minus 2x. Now what's going to be left over is everything else. So if I take this one out, what I'm left with is 2 and negative 2 and an x. That's a negative 4x. Okay, so I get negative 4x right there. Then I have plus. Now this one over here, I'm removing one of them. So I'm going to have a 24 minus 2x left over on the inside, and then that's going to be the correct factoring step. I'm going to simplify inside the parentheses there, so I have 24 minus 2x, and then inside here I'm going to simplify that. I'm going to get 24 minus 6x. Alright, So now what I'm going to do is I'm going to set both of these equal to 0, and when you do, you're actually going to get two answers here. So setting them both equal, you're going to get that you'll get x is 12 from this first one, and then this one you're going to get a 4. Okay, that makes both of these, that makes the derivative equal to 0. Now let's talk about these two. Are you going to have two answers? Let's talk about that. Let's look at x equals 12. What happens if we have x is equal to 12? If I put 12 into one of the sides, we know that this side right here was 24 minus 2x. What's going to happen is I'm going to get a side of 0. Okay, so if I have a rectangle that has a side of 0, I basically have a piece of paper. So I'm not really going to have any volume at all. And so it's asking for what's the maximum volume in the box. If I put 12 in here, I'm going to get 0. So I know that can't be the answer, so I'm going to cross that one out. So sometimes you may get more than one answer, but you got to check it back with the actual problem itself to see if that actually makes sense with what you have. Then I have a 4, and that's okay because I could put a 4 in here, and that's fine. So this though is not going to be the answer because it's not asking you for a dimension. You got to read the question carefully. It says find the maximum volume of the box. So I'm actually going to put it back into this one here. So I'll do that over here. We're doing technically v of 4 right here, and we're putting 4 back into that equation right there. So 4 times 24 minus 2 times 4, now that's going to be squared. And when we find the answer here, that will be the answer to the question that they're asking us for. 24 minus 8, and you're squaring that times 4. Your final answer, if you combine all that, it's going to be 1024, and that's going to be, because it's talking about a volume, that's going to be cubic inches here. Okay, because again, volume is length, width, height. You're multiplying three things together. So therefore, your final answer, that's the maximum volume that you could have with these materials that's provided. It's going to be 1024 cubic inches.